You are sitting still right now, completely still. But here's the thing. You're also hurtling through space at 30 kilometers per second. That's 30,000 meters. Every single second, you didn't feel it. You didn't pack for it, but Earth dragged you along for the ride. Welcome to physics, the science that explains literally everything, from why your coffee gets cold to why galaxies eat each other for breakfast. Let's go, fast. Section 1, motion, the basics okay. Before rockets, before black holes, we start with you, walking to the fridge. The total path you walk, that's your distance. But the straight line gap from your sofa to the fridge, that's displacement. Direction matters there. Now, your mass is how much stuff you're made of. Not weight, stuff. You'd weigh less on the moon, but your mass? Same, you're still you, just bouncier. Now you're moving at how fast? Speed says you're doing 5 km/h. Velocity says you're doing 5 km/h toward the kitchen eastward. One has direction, one doesn't. Velocity is the GPS version. Speed is just the speedometer. And if you suddenly smell pizza and speed up, that's acceleration. The formula is clean. A das v s t acceleration equals velocity divided by time. Simple, beautiful, delicious. Section 2, Newton's laws. The rules of the game now. Here's where Sir Isaac Newton shows up. The man got hit by an apple and changed science forever. Respect. His second law is the one everyone needs tattooed somewhere. Ma force equals mass times acceleration. Translation, the harder you push something, force, the faster it moves. Acceleration, unless it's really heavy. Mass. Push a shopping trolley. Easy. Push a parked car. You need way more force for the same result. That's F-I-R-M-A in your bones. Now his third law, action and reaction. You push the ground. The ground pushes you back. That's why you move forward when you walk. A rocket blasts gas downward and one shoots upward. Every action has an equal and opposite reaction. Physics doesn't play favorites. And then there's gravity, Newton's most famous discovery. Every mass pulls every other mass toward it. That's why you fall down. That's why the moon orbits Earth. That's why Earth orbits the sun. But wait, if gravity pulls things inward, why doesn't the moon just crash into us? Because of centripetal force. Imagine swinging a ball on a string. The string keeps pulling it inward, centripetal force, but the ball keeps moving outward due to inertia. Balance those two, you get a perfect orbit. Section 3, astronomy. The big picture. So we have orbits. Let's zoom out. Way out. Kepler's first law, the law of orbits. Planets don't orbit in perfect circles. They orbit in ellipses, like a squashed circle. The sun isn't even in the center. It's slightly off to one side, at a focus point. So Earth's distance from the sun changes throughout the year. That affects seasons. That affects everything. Kepler figured this out in the 1600s, without a calculator. Respect him. Now, what if gravity gets extreme? What if a star is so massive, so dense, that not even light can escape its gravity? That, friends, is a black hole. It's not a hole. It's not empty. It's the most stuff crammed into the smallest possible space. The gravity is so intense that space-time itself bends around it. If you fall into one, we'd watch you slow down at the edge, frozen in time, redder and redder, until you vanish. You, however, would not enjoy the experience. Section 4, mechanics and energy. How things work back to Earth. Back to physics you can touch. Ever tried to open a really stiff jar lid? You don't push harder. You use a longer grip. That's torque. Torque is rotational force. More distance from the pivot plus more force. More torque. That's why door handles are at the far end of the door. It's not design. It's physics. Now, energy. Pick up your phone from the floor. While it's in your hand held up, it has potential energy. Stored, waiting, like a threat. Drop it. That potential energy converts into kinetic energy. Energy of motion. Crack. And here's the rule that governs the entire universe. The law of conservation of energy. Energy cannot be created, cannot be destroyed. It only transforms. Your food becomes movement. Movement becomes heat. Heat becomes sound. But the total? Always the same. The universe is the world's most obsessive accountant. Not one joule goes missing. Ever. Section 5. Thermodynamics. The universe is messy. Speaking of heat, let's talk thermodynamics. You know how your room gets messy on its own, but it never cleans itself on its own? That's entropy. Entropy is the universe's love of disorder. Things naturally move from organized to chaotic. Ice melts. Perfume spreads. Civilizations crumble. The first law of thermodynamics says energy in a system is conserved. What goes in must come out. We just covered this, but now with heat in the picture. The second law of thermodynamics says, in any energy transfer, entropy increases. The universe gets more disordered over time. Always. You can clean your room, but you'll use energy to do do it, and that energy will produce heat, which adds entropy elsewhere. You cannot win against entropy. You can only manage it. The universe always gets the last laugh. Section 6. Electricity, the flow of power, all right, new topic, but same universe. Electricity. Imagine water flowing through a pipe. The pressure pushing the water, that's voltage. The amount of water flowing, that's current. The resistance the pipe puts up, that's, wait for it, resistance. And the relationship between all three? Ohm's law, V amps IR voltage equals current times resistance. Double the resistance, the current drops. Increase the voltage, the current rises. It's the traffic law of electrons. Every circuit, every phone charger, every power grid, Ohm's law is running the show. Section 7, Electromagnetism, electricity's secret twin. Here's where it gets wild. If there's electricity, there must be a magnetic field. In 1820, a scientist named Oersted placed a compass near a wire carrying current. The needle moved. He had just discovered that electricity creates magnetic fields. That was the moment physics changed forever. Now, how do you figure out which direction the magnetic field points? You use the right-hand thumb rule. Point your thumb in the direction of current. Your curled fingers show the direction of the magnetic field. Try it. Yes, right now. And if you put a current-carrying wire inside a magnetic field, it experiences a force, a push. That's called thrust, or electromagnetic force. To find the direction of that thrust, Fleming's left-hand rule, index finger, magnetic field direction, middle finger, current direction, thumb, direction of force, thrust, 3 fingers, 3 answers, 1 hand. Electric motors, MRI machines, speakers, all use this principle. Section 8, Electrostatics. When charges just stand still now, what if the charges aren't moving at all? Welcome to Electrostatics, the physics of stationary charges. Rub a balloon on your hair. It picks up charge. Hold it near tiny bits of paper, they jump. Like charges repel, opposite charges attract. And Coulomb's law tells us exactly how strong that attraction or repulsion is. The force between two charges is proportional to their magnitudes, and inversely proportional to the square of the distance between them. Move them twice as far apart, the force drops to 1/4. That's Coulomb's law, the gravity of the electric world. Lightning, electrostatics going dramatic. Touchscreen phones, electrostatics going useful. Section 9, Fluids and waves, the physics of flow now. Let's talk about something you feel every time you shower, swim, or stand in the wind. Bernoulli's principle. When a fluid, liquid or gas, speeds up, its pressure drops. That's why aeroplanes fly. Air moves faster over the curved top of the wing. Lower pressure above, slower air below, higher pressure. That pressure difference lifts the plane. Faster flow, lower pressure, slower flow, higher pressure. Your shower curtain blowing inward? Bernoulli. A football curving midair? Also Bernoulli now. A wave's sound is a wave. It travels by compressing air particles. The number of compressions per second? That's frequency. High frequency, high pitch. Low frequency, low pitch. And here's a fun one. The Doppler effect. You know how an ambulance sounds higher pitched as it comes toward you and then drops as it passes? That's the Doppler effect. The sound waves are being squished together as the source approaches and stretched apart as it moves away. High pitch approaching, low pitch leaving. And this doesn't just apply to sound. Section 10. Light. The fastest thing in existence, light is a wave too, an electromagnetic one. When a star moves toward you, its light waves get compressed. They shift toward the blue end of the spectrum. Blue shift. When a star moves away from you, waves stretch. They shift toward red. Red shift. This is how astronomers know the universe is expanding. Every galaxy is red shifted, moving away from us. Mind blown. Now, light can bounce. That's reflection. Mirrors. Shiny surfaces. Your selfie camera. Light can also bend when it passes from one medium to another. That's refraction. That's why a straw looks broken in a glass of water. That's why lenses in glasses correct your vision. And visible light is just one tiny slice of the full electromagnetic radiation spectrum. UV rays give you a tan or a sunburn. No SPF shame here. X-rays see through your skin, reveal your bones. Gamma rays, nuclear reactions, cancer treatment, very much not for casual exposure. CMBR, cosmic microwave background radiation, the leftover glow from the Big Bang itself. Ancient light, 13.8 billion years old, still traveling, still detectable. The universe's oldest selfie. The conclusion, so there it is. From you walking to the fridge, to the leftover light of the Big Bang, motion, force, gravity, energy, heat, electricity, magnetism, charges, waves, light, one universe. One set of rules, running everything. And here's the thing, you didn't need a PhD for any of that. that, because science is not hard. It's just how the universe plays. And now, you know the rules of the game. Outro music. If this blew your mind, smash that like button, subscribe to Logic Uncovered, and tell us in the comments which part of physics surprised you the most. We'll see you in the next one.